Okay, so we will start the context free grammar. We will introduce the we will define what do we mean by context free grammar. So, it is basically a 4 tuple. So, context free grammar is a 4 tuple which consists of V, which is the set of variable, P set of terminals, or P is the set of propagation or set of rules, and this S is a starting variable, S belongs to V, S is a starting variable. So, what is V? V is the it is a finite set of variable, V is the set of variable, okay, and this set is finite and it is non-empty. So, V is non-empty. So, V cannot be empty, but this is finite, finite of this is finite. It is finite set of non-empty, a non-empty set of variables. And what is T? T is the terminals. Again this set is finite. T is the non-empty, finite non-empty set of terminals. Okay. That means which elements are called terminals. And P, and here we have V and T, there should not be any intersection with V and T. I mean a terminal cannot be a variable and a variable cannot be a terminals. So, that means they are two disjoint set, okay. And the P is the rules or the productions. This is also finite, finite set of productions or rules. Okay. So, this P will be of the form say A is a variable, A is going to alpha, and this alpha could be I mean any string between. So, alpha is coming from V union T star. So, alpha consists of including the variable, any string consists of variable, terminals, anything, but here right hand side it should be a variable, right hand side it should be a variable A, but the left hand side A is producting to alpha or A is going to alpha kind of thing. A is this is the rule, A is going to alpha, and alpha could be anything, alpha could consist of B, C, then some terminals like this. We will take an example like this, but this alpha is belongs to alpha is a string consists of variable and the terminals, and alpha could be epsilon also, that is why we have put a star over here. And S is a special variable which is called start variable. S is a start variable. Okay. So, S belongs to V, S belongs to V, which is a start variable. This 5 tuple is called a context free grammar. Okay. So, we will take an example, then it will be more clear. We will take an example of a context free grammar. So, let us take this 4 tuple. So, we have only one variable, that is also starting variable, and we have many terminals. So, plus, star, bracket, this bracket, then ID, these are all terminals, and then we have a rules and we have start, because there is only one variable, that itself is a starting variable s. Okay. Now, we have to define the p, the rules. So, rules we can have like this. So, E is going to E plus E. So, remember this all this belongs to V union T star. So, this is a string of variable and the terminal both, but this side it will be it must be a variable. So, that is the, so this is one rule. So, it consists of P consists of the rules. So, E star, this is star, this star is nothing to do with our this star. Okay. So, this is a symbol star, it could be multiplication in the arithmetic sense. This one, and E is going to I d. These are the 4 rules we have. Okay. So, this is a context P, this is a context P gamma, CGF, context P gamma. Okay. And these are the productions rules, these are the productions. E is, this is the arrow means is going to, going means the production, E is producing E plus E, E is producing E star E, E is producing bracket E, E is producing I d. So, this is the production set and that is P. Okay. Now, we will have some language which is we can have some derivation. What do you mean by derivation? So, suppose we have given this, then we have to define the derivations like this. So, derivation means we start with a variable and using the productions where we can go like this. So, if it is by one production rule we will apply, this is a direct derivation, otherwise it will be star like this. So, E is, so let me just write, these are the rule. Now, E is going to, we can take any one of this, say we take this production E star E. Okay. Now, this E star is going to, again this E, we can take any of this production, then again any one of this E, we take this E, using this production we can write this as I d. Then again this E, we can use this production, we can write this E plus E I d. Okay. Then again we can use this E, using this production we can write E plus I d star I d. Then again we can write this using this I d plus I d star I d. So, this only this is, there is no variable in this string, this string only consists of the terminals. So, eventually we can reach to, we can derive, this is the derivation, we can start from the starting variable and we can eventually reach to a string, we can reach to different strings. So, those are basically, if we collect this, those are called language of this grammar. We will formally define that. This is one of the string of terminals, terminals is this one. We have only this, no variables, we do not want any variables in the final state. Okay. Final state is consist of only string of terminals. So, this is called derivations. So, now this is one derivation. Now, if we have multiple derivation, we can say that star, I mean the multiple derivation we are reaching here, I d plus id bracket star id. This star means we are applying, if it is direct one derivation, then we can just use this derivation symbol, otherwise it is star. Okay. So, this is so this is the final one. We want no variable, only the terminals, and those will be collecting, those string of terminal will be our language accepted by this context free grammar. We will formally define that. So, let us take another example. Say Palindrome. Palindrome strings. Palindrome means if we read, I mean reverse is also same as the forward string, like this string 1 epsilon 0 1, these are all palindromes. Now, if 0 w 0 is a palindrome, where w is a palindrome, or 1 w 1 is a palindrome. Okay. Now, we want to have a context free grammar which is accepting the palindromes, like in the final terminal string will be the palindrome. So, that we want to do that. So, that is a G palindrome. So, we can have a starting state, we can have only one state, then the 0 1, the rule, and S. S is only one state. Now, the rules will be from this we can observe, because these are all palindromes. So, E can go to epsilon, or E can go to 0, or E can go to 1. These are the direct options, or E can go to 0 w 0, or E can go to 1 w sorry 1 E 1 E 1. Okay. So, this is the way we define the rules of the palindrome grammar. So, now this there is another way to write this productions. So, we have this E is going to many things, E is going to epsilon, E is going to 0, E is going to this. So, this we can combine and write in the same line like this. E is going to epsilon or 0 or 1 or 0 E 0 1 E 1 like this. So, just it is a in a one line we can write this, because all the variables are E. So, E is going to either epsilon first rule, E is going to 0 second rule, E is going to 1 third rule, E is going to E 0 E 0 fourth rule, E is going to 1 E 1 fifth rule. This is just the another way of writing this, nothing else. Okay. And this is accepting all the palindromes. Okay. So, now we will we'll formally define the language accepting by a context free grammar. So, suppose you have a context free grammar G, which is V, T, P and S. Okay. So, this is our CFG. Now, we already have this symbol, the derivation. Derivation means we have like a if there is a rule in this P. So, suppose A is going to beta, this belongs to say P, this is a rule. Okay. Then if we have alpha A beta, this we can say this is going to alpha, A is going to beta, sorry, this is gamma, alpha A gamma, this under G. This is the derivation, because we have a string A alpha A beta, alpha A gamma. Okay. Alpha gamma could be anything, it could be variable. Now, we have a rule in P where A is going to beta. So, that direct rule we can apply here, A is going to beta, and that is the derivation. So, this string is going to this string, this string is derived from this string by direct application of this. Okay. So, that is the meaning of this. Now, if you repeatedly apply this, like again if say like this, suppose we have say A is going to beta A alpha, okay, or A is going to epsilon. So, what we can say? So, we can just start writing deriving. So, A is going to beta A alpha. So, again we can say this A is going to, so A is going to beta A alpha. So, beta A alpha alpha. Now, we can just write A is going to alpha, or we can take more. So, beta alpha alpha. So, basically A is this is derived from A, but not by the single rule. We have applied the multiple rules. So, that is why we can write this is star beta beta alpha alpha. So, this is derived from A by applying the more than one rules, that is why it is star. Okay. So, that is the just the notations, derivation notations. Okay. So, yeah. So, now we will define the language accepted by this grammar G. So, that is denoted by L of G. So, this is the set of all string of terminals. In the language we do not have string of variables. So, this is only the string of terminals, such that we have from S we can derive W by applying the repeated, I mean multiple rules using the rules of G. Okay. So, there are two things are there. So, this has to be at this W, this string is a terminal. So, this language is consist of the string of string of terminals only, and this terminal should be reached. Reach means this terminal should be, this string of terminals should be derived from the starting variable S. Then this set of string, if we gather this set of string, is called the language of the context free grammar, and this is yeah. So, this is the language of the context free grammar, language of the context free grammar G. This is L of G. Okay. Now, when we say given a, so we can take some example before that we go further. Yeah. So, suppose we define this V T P S, where V is only one symbol S and T is terminals, which is consist of A B, just a input alphabet which you have seen, and the P consists of the rules is say S is going to A B, S is going to A S B or S is going to A B. This is a context free grammar. Now, we want to find the language accepted by this grammar. So, what are the language accepted by this grammar? So, it will be the all string of terminals where we can reach from which can be derived from the starting variable S. So, we start with S. So, we can just take either one of the rule. So, A B can be derived. So, A B belongs to A B is the string of terminals. So, this L of G, this consists of A B. Then what is the next? So, from S we can apply this rule A S B, then we can apply A B. So, A B B. So, this is A square B square, this is also set of terminals, this is also string of terminals. So, this is A square B square. Okay. So, similarly, we can take. So, that means this A square B square can be derived from S using the rule of G. Okay. Now, what about next? Next is say we can, instead of applying A B, we can keep on apply this. So, we can apply again this rule, the first rule, first production. So, again S is going to A S B B. So, again we can apply S is going to A B, then it will give us A cube B cube. Okay. So, that means A cube B cube is derived from this S by applying the rules of G. So, S A cube B cube. So, in general it is A n B n, where n is greater than or equal to 1. So, this is the language. You remember this language? If you just A to the power n, B to the power n greater than 1, this language we have seen earlier, and we have proved that this language was not a, this language is not a regular language, but this language is a context free language. That means, we have a context free grammar which is accepting this language. Okay. So, anyway, we will define the context free language. So, let me define the context free languages CFL. Okay. So, we have given a input alphabet. So, that is a finite set of alphabets. Now, we say this is a we have a subset of star. We say this is a context free language if there exists a context free grammar G, which is V, P is nothing but sigma over here and the rules and some S, such that this L is such that this language of G, which is nothing but all this string of terminals, here terminals is the sigma, such that S can be, I mean this W can be derived from S using the rule of G, and this will be L. So, if we have a context free grammar from which each of the string can be derived from that starting variable, then we say this is a this collection is a context free language. So, which will corresponding to this context free grammar, and this is the language of the context P grammar. Okay. So, yeah. So that means just now we have seen the language like a to the power n, b to the power n. So, a to the power n, b to the power n, where n is greater than 0, greater than 1. Okay. Now, this we know this is not regular, but this is a context P language, but L is a context P language. Why? Because just now we have seen we can have a context P grammar. So, V we can have just only one variable S, and then we have sigma A B or T, we can say terminals, and the P is nothing but S is going to A S B or A B, these two rules, and we have S, and C L of G is nothing but L. Okay. So, this is a context P language, but it is not a regular language. Okay. We will talk more on this. Thank you.